Cybersecurity students competing in Korea's Best of the Best program have developed Bootkitty, the first UEFI malware of its kind that's designed to target Linux systems. Bootkitty is a bootkit, which is similar to a rootkit, but targets the master boot record instead of the root file system. This kind of malware is particularly nasty because it can stay on your machine even after you've done a full reset of your operating system. Now, luckily, this Bootkitty malware is just a proof of concept for how bootkits could be used on a Linux system and hasn't been discovered in the wild yet with an actual malware payload. But it still serves as a stark reminder that simply switching away from Windows, which has been plagued by numerous bootkits like Black Lotus, and not to mention thousands of other malware strains over the years, isn't a magic bullet for protecting yourself from the most dangerous family of malware. So let's take a look at how Bootkitty works and how systems could be patched to defend against threats like this. The bootkit's main goal is to disable the kernel's signature verification feature and to preload two ELF binaries via the Linux init process, which is the first process that's executed by the Linux kernel during system startup. Bootkitty uses a self-signed certificate, so it's not able to run on systems that have UEFI Secure Boot enabled, so the malware uses a vulnerability that was discovered last year called LogoFAIL to bypass those secure boot protections. When you first boot your computer, a logo for the company that developed your BIOS or UEFI firmware is displayed on the screen briefly, along with a message to press F2 or some other function key to enter the setup of that UEFI system. And usually, this logo that's displayed is just a simple image file. But in the malware sample that was shared in the Rootkit Researcher Discord, you can see that there's a file here called logofail.bmp, which is 16 megabytes in size. Now, at first, a bitmap file that's this large might not raise any eyebrows because that's an uncompressed and lossless image format that also supports an alpha channel. A 4K bitmap image, for example, can easily be much larger than this. But all of these ideas of this being a legitimate image file go out of the window as soon as you examine it a little bit closer. The supposed image is actually negative 768 pixels wide and 0 pixels tall, which causes an overflow of the BMP decoder DXE module that ships with insyde-based UEFI firmware. Then, if you load this third section of the hex dump with the repeating 90s into a disassembler, you'll see that that's actually a NOP-SLED, which is a common technique to make a program jump to a specific address in memory, even when stack randomization is being used. And finally, this fourth section, which you can even identify somewhat in the hex dump, contains the certificate for Bootkitty. So when you put this all together, the LogoFAIL vulnerability gets triggered by the strange image resolution, which grants the attacker arbitrary write abilities. The NOP-SLED gets them to the area of memory that they want to write to, which in this case is the machine owner key database, which contains certificates of programs that are trusted by the secure boot configuration. And of course, the certificate for Bootkitty is what they want to write to that database, making it a program that is now trusted by your system. And this effectively disables kernel signature verification, which allows the loading of unsigned kernel modules without any detection. Normally, it's possible to add or remove machine owner keys from within the operating system, but when you do that, your sudo password is required. However, this vulnerability bypasses that check as well. Once Bootkitty is executed by the shim, it checks to see whether UEFI Secure Boot is enabled by examining the value of the Secure Boot UEFI variable and proceeds to hook two functions from the UEFI authentication protocols. First is the EFI Security 2 Arch protocol, which is used by the firmware to verify and measure the integrity of UEFI PE images. Bootkitty modifies the output of that so that it always returns EFI success, meaning that the verification will always succeed. and the EFI Security Arch Protocol file authentication state function, which is used by the firmware to execute a platform-specific policy in response to different authentication status values, is also modified so that it always returns EFI success, again, meaning that the firmware can use the file regardless of its actual authentication status. After checking the status of UEFI Secure Boot, Bootkitty then loads the legitimate grub file from the hard-coded path on the EFI system partition and makes patches to grub's code in memory before executing it to disable grub's integrity checks. Then the malware patches the Linux kernel as it's decompressed and loaded into memory. And the first change it makes there is to make the module sigcheck function always return 0, which will let the kernel load any module without verifying its signature first. And as you already know, init is the first process that the Linux kernel executes. And this process can be run with environment variables. So the Bootkitty malware loads in this ld preload equals this injector.so file inside of the op directory. So the contents of this shared object are loaded first, and then from here, other malicious actions can be taken on your system. Now, since this is a proof of concept, there aren't any ransomware or reverse shell payloads that are attached to this particular version of the bootkit. In fact, the only really noticeable changes that Bootkitty will make on your system is to rewrite the kernel version in Linux banner strings to include the text BOB13, which is probably a reference to the Best of the Best contest that the students who made this malware were competing in. And Bootkitty will update your boot logo from the malicious BMP that contains the shellcode to this one that has a happy little kitty cat on it. But obviously, this malware could easily be modified by a malicious person to do some evil things on your system and not rename your kernel or change the boot image, which would give away that your system is compromised. So how can you protect your system from this UEFI malware? Well, the initial exploitation, of course, relies on the LogoFAIL vulnerability, which has been patched in both the Intel Management Engine and AMD's generic encapsulated software architecture. So the best solution is to just apply those UEFI updates to your system, which almost nobody does. But they are important because sometimes they close attack vectors for bootkits like this. If you enjoyed this video, please like and share it to hack the algorithm, and check out my online store, based.win, where you can buy my stylish merch or accessories for your phone or laptop. 10% automatic discount at checkout when you pay in Monero XMR. Have a great rest of your day.